So we will wait for 2-3 more minutes to see if anyone joins. Then we will start the session. Hi, am I audible? Yeah. So let's see how many joins. Wait for we will start at 6 to 6:04 like that. Okay, so let's start. Uh, okay, so let's start. Hello everyone. My name is Rajan Mukherjee, and I will be taking this live session for NPTEL course on programming in modern C++. We will be solving some questions which are related to your assignments, and the questions which will be asked in your final exam. So this is a interactive session, so please feel free to ask any question in the middle. I will be replying them. So just you can just open your mic and ask any question whenever you want. Uh, so this week we will cover the topics that were taught in week 6. So let's start the session for today. So we'll be covering week 6 like items that were there. So in week 6, let's do a small recap of what was taught in week 6. So, in uh, week 5, we are introduced to inheritance. So we saw how inheritance occurs and what is the need for inheritance, like what is uh, base class and derived class. We also saw the fundamentals of overriding and overloading of member functions. we saw what happens like when a derived class uses a member functions, has its own member function which has the same signature as that of a base class. So what were the difficulties that were facing, and what was the logic behind every mechanism. We also saw uh, access specifier, like the types of inheritance: public, private, protected. Specifically, we deep dive into the deep dive into how why protected is used, and why not. So protected is mainly used so that the member functions can access private, like those member functions of derived class can access those members of base class which object of its cannot access. So that was the reason we are using protected. Next, if we come to this week's thing, week 6, we are introduced to the topic of binding. What is binding? Static binding and dynamic binding. So we saw the main culprit of this binding problem derives from the function overriding thing. So the main problem of static binding derives from the function overriding thing. So so uh, to do it, we allowed the C++ allow uh, dynamic binding. Dynamic binding through virtual functions. Uh, we have seen that if we have a class A and we have a void virtual func and class B publicly inherited A, if it has a public void func. So using virtual, we are able to solve the problem of like dynamic, like we were able to solve the problem of uh, dynamic static binding. So now uh, object of A can hold like A can hold an object of B, and when A does func, it can directly access this func of class B, whereas previously without this virtual it was always accessing this func. So this runtime binding helped us in overcoming the type casting issues that is generated during upcasting. So we saw that using virtual, using the virtual thing, we can actually solve these issues. Now uh, another thing, like after getting introduced to virtual functions, we saw what is a pure virtual function. A pure virtual functions like they are generally defined as func. So we saw that when we declare a function as pure virtual functions, uh, they not necessarily be defined inside the base class, but every public class can every public base derived derived class should have a definition of this pure virtual function. Next, we were introduced to the concept of abstract class. So any class with have one or more pure virtual functions were called an abstract class. The main purpose of abstract class was that those classes, the objects of those classes are not generally created, but those classes are generally only used for inheritance, and the derived class uses that structure of the abstract class just as a skeleton, and it populates its own variables. We will come to a very good example of this at the end of the lecture, like why abstract class is required and why uh, it is used uh, in like system building kind of things. So these are the few things uh, uh, that were discussed in this week's class. In week 6 topics these were covered. So we will now come to the questions, and like if you have any doubt you can ask regarding that. Uh, so let's start. So this is the first question. So you have a class A. It has two public functions, member functions. One is void fun1, and then another is a virtual function void fun2. Class B, which is a public inheritance of class A, has two functions, fun1 and fun2. So we have a main functions, int main A. Class A is equal to class A t is equals to new class B, and we are calling using t both the functions func1 and func2. Now the question is, what will be the output? What will be the output? So we are as from the question, it like from the code we can see A has a virtual function, and fun1 and fun2, and these have a these are the functions of class B. So this function is non-virtual, so it will be overridden. So but this one will be virtual. Now we are creating a object of class B and we are storing it in a pointer of class A. So we are creating an object of class B and we are storing it in a pointer of class A. So when we are doing t dot fun1, when we are doing t dot fun1, so which one will be called? This one or base class, or of class B's fun1 will be called, or class A's fun1 will be called. So in this case, class in the first case, class A's fun1 will be called, because it is not a virtual function, so it will use its own fun1 function. So it will print 1, and this when this pointer accesses fun2, at that case fun2 is basically a virtual function. So in this statement, B's fun2 will be called and it will print 4. So the correct answer would be 14. So the output will be 14. Any doubt regarding this? This is a very basic question. So any doubt regarding why, uh, how virtual functions are working in this case? Okay, so let's go to the next one. So you have this program and we have to find out what will be the output. So here you have class A, that is the base class, and you have a class B, that is the derived class. Class A has a virtual function and class B also has a virtual has a function fun. So uh, now we have a main function. It first it creates object of class B, then again it creates an object of class B, but it stores in a pointer of class A. Next, it stores address of B in a pointer of uh, class A. Now it goes for T3 equals to T3 fun and T2 fun and T3 fun. So in each case, we need to find out which of these virtual functions are being called, either the virtual functions of class A or class B that is being called. That is the question here. Now how to uh, like the concept is same because we are using a virtual function. So here first, like when T2 calls fun, it will be using this fun because it's simple. It sees that it has a virtual function here, so it will dynamically we'll be using uh, so dynamic binding, and it will use this fun as a result. So B's fun will be called. Same in case of T3 fun. Uh, Again the same. It's basically storing a object of T3 is basically storing an object of class B. So B's fun will be called due to dynamic binding. So in this case the correct answer will be D, 2D. So if you have any doubt regarding this, you can ask. Okay, so let's go to the next one. So by the way, in this question, we have like a base class and a derived class and the external function fun and a main. Now the question is what will be the output. So we will see one by one how each one is getting executed. So first let's come to the main function. So the main function calls the fun function, and it prints the value of x. X is a global variable with value 0, and it does so. Inside fun, what we are doing, we are creating an object of derived class T. Then we are creating another object of derived class, and we are storing its value in pointer T1. Next, we are printing the value of current x, and then we are deleting T1. Now inside, as you can see, inside base and base class and derived class, only thing we have is a constructor and a destructor. So let's start which constructor are being called and which destructor are being called at each phase of this question. So first we are creating derived T, object of class derived, and we call it T. So in this case, constructor of base and derived are called. So the first, the base class constructor, as we know, like last class we discussed how the invocation of constructor and destructor occur in case of inheritance. So always the base class constructors are first invoked and then the derived class constructor are invoked. So in this case, first base class constructor will be invoked. So that is we are increasing the value of, so that is this. So first x will become after this statement, because first the constructor of base class will be invoked, so the value of x will become 3. 0 plus 3 plus 0, 3. Next, this constructor gets called, derived class constructor gets called, so value of x will become x equals to x plus 7. 3 plus 7 equals to 10. Now the value of x is 10. Next, we are again creating a object of derived class. So again the same thing will happen, construction of base class, and then the constructor of derived class will be called. So again x will be 10 plus 3 equals to 13, and x will be 13 plus 7 equals to 20. So now when the value of when we this cout is called, so the value of so 20 will be printed, right? 20 will be printed. Now we come to this statement, that is delete t1. Delete t1 means the object this t1 pointer which we have created, it has to be deleted. So we have to call the delete function. Now you see t1 is basically holding the pointer of base class. Pointer of derived, but it is base. So base, so now since it doesn't have, so these things are not in his hand, so in that case it will just call the base class destructor, not this destructor, because since it is not virtual, it will only use it will be only able to call its own destructor. So x will become x equals to 20 minus 5 equals to 15. Now also this t goes out of scope. So when this when this one goes out of scope, one minute. Now when this one goes out of scope, 1 minute. So when this t goes out of scope, then both base class pointer and derived class pointer derived class pointers will be called. So in that case x will become again 15 minus 5 equals to 10, and then a derived class will be called, derived class destructor will be called, that will be 10 minus 1 equals to 9. Now it will come out of this function and it will go to this cout statement and it will print 9. So in this case, if we summarize what happened in this case, So if you summarize in this case the order of construction calling, so initially for derived T, B's B's constructor will be called, and then D's constructor will be called. Then for this new derived, same B constructor will be called and derived constructor will be called. Now in case of delete T1, only B's destructor will be called, since it cannot access derived destructor, because it have only access to this inside its scope. Next, when this T goes out of scope, then it will call the destructor D for T1 for T, and also the destructor B for T. So only one so in this whole scenario we are only missing one destructor D, that is for T1. So this one only gets missed because it cannot access, T1 cannot access derived destructor. So the correct answer will be 29. So how to solve this problem? How to solve this problem that in this kind of setup, when we are doing upcasting, that the base class, the derived class destructor is not being able to be called. So that will leave a memory leak or a garbage. So how C++ handle this? So C++ handles this lack of destructor call during, so the C++ handles this lack of destructor call during when object goes out of scope using virtual destructors. So in this case, what you need to do is you need to put a virtual derived. This will solve the problem of like of calling the this destructor in case of T1. So this is the concept of virtual destructor that we have witnessed in this question. So if any doubt regarding this? Yeah. So yeah, so I will again repeat. Yeah. So in this case, what is happening? In this case, we have a derived class object T. So when this is called, what happens? T will call the base class object. When object of T is created, the base class and derived class constructor will be called. So this will invoke B, as well as it will invoke constructor of D. Okay, so x value will become x equals to 0 plus 3 equals to 3, and x equals to 3 plus 7 equals to 10. So the value of x will be 10. Now, in this case, what is happening? We are creating a derived class object and we are upcasting it to the base class pointer, right? So when we are creating this object, it will again obviously create it will again do this stuff again, like calling the constructor and the destructor. Now we are that will give rise to 10 plus 3 equals to 13 and 13 plus 7 equals to 20. So value of x currently will be 20 when we uh, evaluate these two statements. Now when we come to this cout statement, it will print 20 as a result. Now we come to this delete statement. What we are deleting, we have basically deleting t1, a base pointer. We are deleting base pointer t1. Right. Now what does deleting t1 will invoke? Deleting t1 will invoke only this destructor, because it cannot access the items of the derived class because of typecasting. We have upcasting. So we have discussed this in previous class, like how upcasting occurs and why it cannot access this part. Now when so these leaves, so we have called the x value will become 20 minus 5 here, 20 minus 5, it will become 15. Now when derived t goes out of scope, in that case it will be okay. It will invoke both d and b, both derived class destructor and base class destructor. So it will do 15 minus 5 equals to 10. 15 minus 10 minus 1 equals to 9. So 29 will be the answer. Okay. So what happens in this case? The problem here happens, these leaves are this destructor which is not being called. That was done in case of t1. Sorry. So this destructor constructor which was called during t1, it is not being destructed. So and this is only, this reason is the reason is it is happening because of outcasting. It is the t1 is not able to access this derived pointer. So like C++ allows us to bypass this using virtual destructor. Just previously we have seen virtual functions. In a similar way, virtual destructors occurs. So when you give a destructor as virtual, so in that case, like here we have like t1. So t1 in that case will be able to call this destructor in virtual derived. So in that case, this will get called, this x minus 1 will get called in that case. So using this virtual derived concept, we, C++ handle this problem that occurs during upcasting. So you are saying if you have a virtual destructor in the base class, and if we do able, would it be able to call mod d for t1? See, virtual destructor in base class, it will not be helpful, right? So if you have noticed here, the problem lies in we are not able to call this one. We are not able to call this d, this destructor call. So you need to define your virtual here only. Yes, you need a virtual descriptor in derived class. See, how can a base knows about his derived class, right? That is not possible, right? That is polymorphism. So derived class, unless you define it as a friend, it is not going to understand. So what do you mean by polymorphic class? Abstract class, right? Yeah, so that is a class with okay, so you can call it a class, any class with virtual functions. But we are dealing with destructors. The destructors and functions are quite different. Okay, any more doubts you can ask? Yeah, okay, I made a mistake. Sorry. I made a mistake. Uh, I made a mistake. Anufa was right about it. I only made a mistake. So you have class B and it has its own B and B, and you have a class D. So now uh, when you are into this thing, B T1 equals to new D, and then you delete T1. Okay, so this is the case we are dealing with. So when this happens, so while this creates with these calls both B and D, when you are calling T1, it will only call uh, B's destructor, because in this case it will only be able to uh, due to static binding, it will only be able to use this one. Now so now if we have to make sure that this also gets called, we need to make this one virtual. Sorry, this one was the mistake I made. You have to make this one virtual, not the you need to make the parent uh, parent constructor virtual. So that will indicate that it is not a static binding, it is a dynamic binding, then it will be able to call this destructor also. So when that is the way we need to implement virtual destructor. Sorry, yeah, we need to put it in the um derived class, like sorry, in the base class, the virtual keyword. Yeah. So I made that mistake. Sorry. So I forgot. So my is like I always thought that that virtual has to deal with the derived, but no, it has to be deal with the. In this case also, it has to go for the same thing. Yeah. So yes, because if you have to like make a thumb rule, you have to make a thumb rule. So always think. So typecasting happens always when upcasting happens when the base class pointer is storing the object of a derived class. Okay, so whenever we are trying to delete the base class pointer, so obviously base class needs to know that it is a dynamic binding or static binding. So how it will know? If the virtual keyword is there, it will be able to understand that okay, this is a dynamic binding. So all of the children's like destructor I also need to call. So that's how it is working in this case. Okay, so let's go to the next one. So this is the one that will help you all. So you have uh, class uh, you have class A, and it has one constructor and destructor, class B constructor and destructor, and class C, and it has a virtual destructor. Now what will be the output? This is a simple case. We are creating a object of class C, and we are storing it in T1, and then we are deleting T1, right? So when you are creating C, what will happen? First, we know uh, constructors of base classes are called. So first it will be A, because A is the first base class of this multi-level inheritance. So first A will be called, then B will be called, and then C will be called. Now when we are deleting it, deleting T1, T1 is basically a pointer of type class A. Now for class A, there is no virtual thing here. So basically, to T1, T1 will think that it has only static binding. So so it will only call its own destructor, and these all destructor of class B and C will not be called. So the correct output will be 4D. Yes. So only if we add a virtual destructor only to class A, that will be enough. Just only adding a virtual to class A will be enough to do all B and C's. Yeah. So any more doubt regarding these virtual destructor concepts and all, you can ask. Okay, so let's go to the next one. So the question is, what will be the output? So in this case, you have a same structure, a base class and a derived class. Base class has a constructor and a virtual function. Derived class has is derived class. This is the constructor. It is initializing the base class function, base class constructor. Base class using this, and this is the initializing B. Now it has a test uh, mm, test function, but it is of type test derived this. Now we are creating a new T1. We are creating a new object of derived class with values 5 and 9. So obviously this will get called, then this will get called. Now next we are calling T1 test with a new uh, with a new derived class. Okay, so in this case we are not passing any value. So in this case it will be 0 0 will be printed, right? So 0 0 will be printed. So and in this test we are printing the value of B. So this is T1. T1 has value 5 and 9. 5 is the value of 5 and 9. 5 is the value of uh, A, and 9 is the value of B. So what will be the output in this case? So first tell me, in this case T1 will call which one? Base test or derived test? So in line 1, which one will get called, base test or derived test? That is a thing that we need to know. So in this case base test will be called. The reason is we are given a virtual to this signature, void test base asterisk, but the test we have here is void test derived asterisk. So these two signatures are not same. So this test basically does not do a is not basically an implementation of this T. So this overriding will not happen in this case. So this is different and this is different. So in this case when we call test T with new derived, in that case in this test, so this base test gets called. So it will print in this case A only. So the 5 will get printed. Any doubt regarding this? So this is a prime example that when we are declaring a virtual function, the signature needs to match. Otherwise, overriding will not happen. Overriding will happen. Why it called base class? Yeah. So you see that the main crask lies in this. You see, this is a void test base star, and this is void test derive star. So this dynamic binding doesn't happen here because these are effectively functions with different signature, right? So these tests and these tests are different because of this signature, like different data types of parameters of the functions. So as a result, when we are calling, when T1 is calling test, it is basically calling this function, not this function. So here is no dynamic binding. As a result, basis base test is getting called. Like the simple reason is you check the test, the signature of the text. The tests are not same. One has a parameter of base star, another has a parameter of derived star. So that doesn't allow. So here it doesn't gets the kind of dynamic binding performance we are asking. It doesn't gets it doesn't happen here. So so uh, if in this case of derived star it was base star, then this will have get called and the output would have been 9. In that case the output would have been 9. If in that like if this test has base parameter of base star, then this one would have been called, then dynamic binding would have happened. Clear this one? No. Okay, so let's go to the next one. So now you have public function here, public class A, and it has a public function print, and then it has a public class B which inherits A, and it has a public function print. So now we are calling print T1 and T2. So the question is what we should put here such that the output is A and B. So effectively we want uh, this one calls B's print and this one's called A's print. So this is what we want. Now we have like we have approached this problem last two classes. So the problem here lies when we are doing this, when we use, so when we use functions, when we use functions of same name as base base class functions gets hidden. So if we do not put something here, this will throw a error. This will basically throw a error if we doesn't if we don't put anything here. So this will throw a error if this one is kept as blank. So a solution which we used for doing this, we will say this thing using a colon colon print. This will, when we use the put this statement at b, so this hiding which happens uh, when we are using functions of same name, so that it gets unhidden. So in that case, this will be available for objects of b also. So this will be the correct answer using a print. Also this one is also correct. You can rewrite the entire code again. So both a and b are correct, but this is the C++ way of doing it. Any doubt regarding this? So this problem we have solved like 2 times now. This using thing. Okay, so let's go to the next one. So here we have uh, a program, and we have to find out the output. So we have a class A, we have a class B, and we have a class C. Class A has a int type int A equals to 5, int type data member. Class B also have an int type data member. Class C has a uh, like double type data member. So now what we are doing in main function, we need to investigate. So we are first declaring a pointer of type A, then we are creating an object of class B and an object of class C. Now we are uh, explicit casting. So we are doing an explicit casting, and we are converting T1 into we are casting T1 into a pointer of P, and we are printing the value of A. Now again we are doing an explicit casting of T2, that is object of C to P, and we are trying to print A. So what will be the output in both cases? So one thing that will help you in this case is, if you if you suppose we have a and its object small a, b and c. So if we use a size of a, size of b, and the size of C. So what will be the output of each in each case? So what will be the output of this and this size of A, B and C? Anyone? This will
8.
uh, 4 or 8.
C is 4, 8, and A and B are 4, 4.
Okay. Okay. So so what like basically the storage in the memory will be like this. So this thing we can agree, right? Double is equals to twice into int. This thing we agree, right? So let me just increase it. So basically, our object of A will only have a int part. This will also have an int part, and C will have a double. Now, when we do this type casting, okay, it will throw a warning. The compiler will throw a warning. But this casting of a pointer of this type from object of this type to pointer of this type, this will be permissible and it will be effective. The only reason it is being effective is because how the object is being stored in the memory. So these also consume 4 bytes and these also consume 4 bytes, 4 bits. So that is the only reason 9. So when we are trying to print this, it will print 9. This is unsafe way of doing it, but and it is also not permissible, but in most cases it will throw a warning. But this conversion will result in this output 9 correctly. But when you are doing this conversion, now it is the issue. So now this is a smaller area and this is a bigger area. So it will not be able to hold this whole value. So it will occupy some amount of space. I don't know which space it is going to occupy, whether the first bit or last bit. First bit most probably, but that will be a garbage value. So uh, this will give a garbage value. So this explicit casting can be done, but that is not the correct way of doing it. So like proceed at your own risk. So these things are not good way of programming. So if you want to do a casting, you have to use like proper casting operators to do it. Okay, so let's let's go to the next one. So now let's you have these functions classes. One is everyone is inheriting someone or else. So the question is which of them are abstract classes. So now we discussed in the beginning what is an abstract class. So abstract class is any class which has one or more virtual functions. It has one or more virtual functions.
Pure
Permissible,
virtual function.
huh?
One or more pure virtual
Pure
function.
virtual functions. Sorry. So one or more pure virtual functions. So so now you can create an object or not, that is up to you, but generally it is not told not to create an object. Mm. Now let's look at each of them. So we have here a pure virtual functions. Pure virtual functions are given like this. So this one is a abstract class. Now we are this is we are doing a inheritance. Now in this inheritance we are not giving any definition of these virtual functions. So the things which are virtual here, pure virtual functions which are here, it will remain a pure virtual functions here also. So this one will also be a abstract class. Now let's come to this one is also inherited from vehicle. Now here we are giving a definition of run, but we are not giving any definition of stop. So stop is still virtual in this class, pure virtual in this class. So this will also be a abstract class. Now let's come to this one, truck. So it is publicly inheriting this. Now here we have given definition for both run and stop. So none of them are now pure virtual functions. Both of them have been given a definition. So this is not an abstract class. Let's come to sports car, which is also a inheritance of car, public car. Here you see you have one virtual pure virtual function, run turbo. So this one is also an abstract class. Next we come to class SUV, which is also a public inheritance of car. Here also they have run and stops like definition. So now, and it doesn't have any pure virtual function. So it is not an abstract class. So vehicle, car, motorcycle, and sports car are are abstract classes. So correct answer is D. Okay, so let's go to the next one. So this is so you have to provide what will be the what we have to write here. So here you have uh, class A. It has a virtual function cout a print statement. Then you have a class B, which is publicly inherited in class A. It has also a print statement. So basically this will also have this will have that dynamic casting thing. Then you have similarly another like derived class of class B, that is class C. It also has that print function, so it will also have that dynamic casting feature. Now we have to write which class we need to define here, and we need to give this CB is calling print, so we need to give something here such that it prints B. So it is simple. So new B is the correct answer, because when it creates an object of class B, it creates an object of class B, and A, when it is trying to like CB, which is a pointer of class A, and when it is trying to do print, it will be able to use this print because of dynamic casting, this virtual function thing. So the correct answer will be new B. So any doubts
It
like,
is,
huh?
sir, here in class A, can we say that it is a late binding because of virtual function?
Yeah, so it is you dynamic binding is basically late binding, right? So runtime you are binding the thing.
So there is no difference between dynamic binding and late binding.
So what do you mean by late binding? Uh, just if you can specify.
If we if we declare the virtual function
Hmm.
before the any functions, like then it's called the late binding.
Okay.
Like here in class A, it is mentioned virtual. Then
Mm-hmm.
after we take one another class B,
Mm-hmm.
it is inherited by A. So in class A, it's a late binding.
So my understanding is late binding and dynamic binding are same, right? So like what you are saying, you only say what is the difference, like in like what is the difference between a dynamic binding and late binding. So by your definition, isn't both same? Because
That's
binding,
what I am asking, sir. I think both of them.
both are same, like these are basically
Yeah, yeah.
term.
That's
Because see, so binding can occur at two times, either in static point or dynamic point. So there is no other place that binding can takes place. So I don't think there is anything later than dynamic runtime stage that binding can occur. Okay. Any more doubts regarding this virtual functions, pure virtual functions, and um, casting up, casting down, casting. Even you can ask the public or private things also. Public specifier, public private specifier, those things. Then we will move to the next part. Okay, so let's come to this one. So this was part of your like this assignments things. So let's just have a quick look at this one. So you have a thing called class called shape, and then you have a class triangle which is publicly inheriting shape. Then you have a class circle which is also publicly inheriting shape. So you have a shape, you have triangle, and you have circle. Now uh, you need to do a fill in the blanks here. Now let's see what these things have. So triangle takes in 2 points A and B, and we are defining it that height and width here, and it has a void area, a member function. In the circle also, it is taking in data function, data member R, and it is calculating the area. So and it is using the AR variable that is stored in here, right? and then it calls the show part and the area part. So here you see is basically shape S1 is storing a triangles object and shape S2 is storing circles object. So here it happens is upcasting, right? Now S is calling area and S2 is also calling area. S1 is calling show and S2 is calling show. So both area is present in here and here. So this has to be a virtual functions so that this dynamic this dynamic linkage can occur, dynamic and so and upcasting can prevail, so that it can access their respective area calculations. So it has to be declared as virtual void area equals to 0. So we are declaring it as a uh, uh, pure virtual functions. So this will be a pure virtual function. So area is a pure virtual function and its implementation is there in both circle and triangle. Next, the other peculiarity is AR. So if we declare AR as private, is this will this be valid? If we define AR is private, will this be valid? The answer is no, because we know in inheritance derived class member functions cannot access the members private members of base class. So triangle cannot be able to, like, this area won't be able to access AR of if it is a private member of same. So we have to make it protected, because in case of protected they are able to access those data members or member functions from inside the member functions of derived class. So the answer in this case, line 1 will be protected and line 2 will be virtual void area equals to 0, a pure virtual function. Correct. Okay, so let's go to the next one. So now let's we have a like similar fill in the blanks. So we have a base class and a derived class. We also have a main function. So the base class has a constructor, two constructor and a destructor. Similarly, derived class has a constructor, another constructor and a derived class and a destructor, sorry. Now we have a main function. Main function takes in a input I it creates a object of derived class, and it calls the it deletes the pointer pt before going out of scope. So these are the inputs. So if I give input as 5, it should the output should be 5, 15, 4, 2. And if the input is 7, so it should print 7, 21, 4, 2. So basically, what is 4 and 2? 2 is basically the destructor of base class, and 4 is basically the destructor of derived class. So number one thing is uh, to call, we have seen in previous slides, to make to call. So if we just give it as a basic destructor, if we define it as just a basic destructor, what will happen? The thing will happen is that in this case, uh, base and derived constructor will be called, but only base destructor will get called if we just define it as this. So in this case, we have seen uh, both derived and base destructors are getting called. So to do this, we need to make this virtual. We need to use a virtual destructor. So we will make it virtual b. Now the next part is, so printing 4 and 2 is now done. Now when we are sending 5, so basically it will this 5 will come here, and that will print 15. But more than that, previously it needs to call the base base constructor, that it will be with the value n. So now we are calling the base constructor in this initialization list. So that will go here, and it will print 5. So two things we are adding. We are adding a virtual destructor. And the next thing we are adding is a base. We are just calling the base constructor. So these are the two things we are doing here. Okay, any doubt regarding this? Okay, so let's go to the next one. So now here is another code, piece of code we have given. We have to fill in the blanks. So here you have a base class B, then you have a derived class D which is inheriting B, and then we have a class Z, just Z. Here you have the destructor of B, D. Now in the main section you are taking two integer cell input, that is I and j, and also you are creating an object for class Z. Then we are calling we are like the object W is calling its function fun with the value ij. So now suppose the input is 5 comma 3, the output is 8 comma 4. So if 5 comma 3 goes here, what we need to put here? So what is happening inside this fun function? So it is creating a object of like it is like something we need to put here, and that is basically t is using fun, fun b. So basically t has to be a object b, like of either this has to be new b or new d, either one of them this has to be. And it has to take in something as input. Right, so what needs to be done? So if 5 uh, is here and 3 is being passed here, right? So if we make it as new d, uh, then what will happen? So is value will like, okay, so nothing is there, so we need to make it, so either, so if you see here, behind b only thing that can be there is virtual. Obviously it is a destructor, so it obviously it will not have something like a return type, so it will only have the thing called virtual. So this will be virtual. So so by making this virtual, we are making sure when t is called, both uh, d, this d and this b is getting called. So what happens in this d, s minus minus is printed. So what is s? We need to store something. So s we can write, and so we can write this as equals to new d a. So a goes here, a goes here. If a goes here, b will become b will pass the a to this s, so s will become 5. So when we are doing this c out minus minus s, 4 will get printed. Now two parts are done. this virtual part and this new day part. So two lines are done. So let's come to the last one. So when you are calling fun, this fun, so b, that is base type pointer, is able to access this one. So x is basically 3, so basically 5 plus 3 becomes 8. So to return this, so basically we need to access this one. So how to do it? It has to be done if we declare it as a virtual function. Virtual int fun int x equal to 0. So if we make it a pure virtual function, then only we'll be able to do it, right? So these will be the three, fill in the blank. So number one, virtual. Number two, this virtual function for fun. And number three is creating a new object for d. So this is how you need to solve it step by step. Okay. So any more doubts regarding virtual functions, virtual class, abstract class, and anything you can ask? So today we have gone through virtual functions, like virtual destructors, upcasting, etc. So let's look at the problem which we were discussing last week, and how abstract class, virtual class will help it more. So you have, so last week we were discussing this. So you have this kind of a database, suppose. Suppose you have a database like this. So you have an organization, like you have an organization like your college, and it has many um, entities which make up this. Like you have staff, a complete generalization, and you have your teachers, you have your officers like director, principal, those are deans, those are basically officers. Then you have let's say a typist, typist, or you can say also a clerk who does all kind of office jobs. Then you have a type, it has also a type called regular, and it has also a thing called casual daily wages kind of thing. Now like now we will see how the concepts of uh, abstract class and virtual functions will drive this system. So you have staff, which is basically a pure general view of this system. So a teacher will also be a staff, a clerk or a typist will also be a staff, and an officer will also be a staff. So some like you need so you don't have to create a complete object for a staff, but it will be inherited by everyone. So inherited by everyone. So a thing like a code, like a employee code or an employee name or maybe a age, gender, those things are common to all of them. So you can put all it into a abstract class. You can just make uh, you can just make this a so you can just make this a abstract class such that none of the such that no object is created and everybody inherits it. Now let's say it can have some functions. So you have this you can have these functions like uh, calculate uh, like calculate wage. So that you can put something like that in your inside this abstract class, and you can make it uh, pure virtual function that you can make it a pure virtual function. So that is how you can like make a system like this, and such that the staff is your abstract class, and some membered functions inside it uh, are pure virtual functions which it will not implement, but others like the teacher, which will have a different uh, wage calculations because of his or her grade, something like that, or based on what subject he teaches, or how many publications which we have. So based on that, he can she can he or she can have a different wage structure. So a typist can also have a different wage structure based on if it is an he or she is a regular or casual. Official will also have a wage structure based on his grade. So these kind of things like well the staff will have that control. So whenever a staff will call a calculate wage thing, so because of being a pure virtual functions and having dynamic casting binding, so irrespective of it is a teacher attribute or a typist attribute or officer attribute, it will be able to access all of them. So that is one of the features uh, that is quite popular for this. So that is how it is being utilized for for these kind of systems. So that is one view of how to use an abstract class. So obviously you have to write these whole codes up for everything and create this. So these kind of like real life problems will happen with you, that they will give you to solve in your question papers or even in your job interviews. Like these questions are quite common, like do you design a system for, let's say, Flipkart or something like that. So like how to online database system you need to maintain, like that. So these kind of design views, uh, like if you write codes and prepare for these kind of things, it will help you a lot, even understanding how things work. like uh, I will give you an example. Like I previously used to work in an industry. So there, we used to make these like networking stacks. So you will have your different layers of network, like internet. So you will have your uh, TCP layer, IP layer. So every one of them has like some kind of common features, but also some kind of exclusivity. So in that case, you need to we used to write the C++ programs for each of this layer actually, but also you need to have that whole layer as a concept, so that each one can derive from it the things. So these are very important. Like okay, so like the topics were being taught in just 3 slides, but these are very important topics to grasp, and it is like used very commonly. So one more thing, let me ask you. Uh, let's say, like if you can we make this class which is being inherited by regular and casual, can this also be made um, an abstract class?
Yes, sir.
So okay, so you can make it obviously by mere giving it as a concept only, like a pure virtual function, like defining it. But like, is it helpful just giving a only a pure virtual function and doing it? Like obviously, like it is not always required that this kind of things are always has to be an abstract class. Sometimes you need to have a object for that also. So uh, having something like that uh, helps, but it is not a like a hard and fast rule that all abstract classes will not have a object. So these are quite big designing tools, designing schemes that you can make using these concepts of C++, like inheritance, uh, like abstract class, pure virtual functions. And the good part of this is this concept like abstract class which you are learning in C++ or this pure virtual function. These are present actually across all other object oriented programming. So if you go to Java also, there also this concept of abstract class is there. There is also this concept of pure virtual function is there. So once you learn the topics here, so it will be very helpful if when you pick up another programming language like Java, that is which is also a object-oriented programming, because the concepts are same and implementations are also same. So it will be very easy for you to understand once you understand these points. Okay, so if you have any doubt, you can ask regarding this week's, or shall I repeat all the problems one more time? So let me just go back. So so this was one of the initial thing we did. So whether overriding happens or not. So one thing also is that which we should remember, static binding leads to overriding, function overriding, dynamic binding, no overriding. So like the problems like this will show you that overriding is a very troublesome concept. So always it is better to use virtuals whenever to for just to resolve the scopes and all, such that overriding doesn't become a pain for you. We also saw the fun of like dynamic bonding. Then we discussed why virtual destructors are important, and what happens in if you don't use a virtual destructor. we, it's a like you will have that memory leak when this when a destructor of the derived class is not being called due to static binding case. So that is one thing we was discussed. uh, the same concept of a virtual binding, a virtual destructor. Then we also saw a concept like why in this case virtual like dynamic binding was not happening. Instead in spite of having virtual, so the reason was the signature. One was having a derived type, another was of having a type base. So no like virtual function, instead of having virtual functions, no dynamic binding was happening. So that exception we also went through. We also saw like how overriding can be done, like the data hiding feature when two functions have same name. So you can use the using thing which we have discussed in previous weeks also. Then we saw the emergence of why explicit casting is bad. So it can create garbage. We saw. Then we went into the abstract class things. What is abstract class? What is pure virtual functions? And then finally the dynamic linkage thing. Okay, so with that we come to an end of today's one. Hope we'll again join next week, same time. So if you have any doubt, you can ask, or you can leave for today. Thank you everyone for joining.